Okay, so in today's video, we are considering college and university students. We're looking at calculus, finding the intervals of increasing or decreasing functions. So I've sampled out some questions on finding the intervals of decreasing or increasing function. So the first one, we have find the intervals for which the function f of x is equal to 2x to the power 3 minus x squared over 2 minus 2x plus 5 is decreasing. So you have to find the interval for which this function is decreasing. So these are the conditions. If a function, I'm going to write my answer here. If a function is decreasing, it means that f prime of x, the first derivative of the function, must be less than 0, meaning the function is decreasing. So I have my function f of x, which is equal to 2x to the power 3 minus x squared over 2 minus 2x plus 5. I have to find the interval which this function is decreasing. Our condition is that the first derivative of this function must be less than 0. So I'm going to differentiate this function. So I'm going to say f prime x will be equal to. So in differentiating, multiply the coefficient with the power. The coefficient multiplied by the power. Then the power reduces by 1. I'm differentiating it. Again here, I have minus. So the coefficient of this function is 1 over 2 multiplied by the power 2. Then the power is reducing by 1. Then I have minus 2. This one minus 2x to the raised to the power 1. So I'm going to multiply the coefficient 2 multiplied by 1. Then the power reduces by 1. Then the derivative of a constant is just 0. So f prime of x, 2 times 3, I'm going to get 6. X, 3 minus 1, I'm going to get a 2. This 2 and this 2 can cancel each other. 1 times 1, I get 1. X, 2 minus 1, I'll just get minus x. Then negative 2 times 1, I'll just get a 2. Then x to the power 0. I know that any number raised to the power 0 is a 1. So it is 2 times 1, I'll just get a 2. So this is my f prime of x. So if the function is decreasing, it means that this function 6x squared minus x, this first derivative is less than 0. Okay, are we together?
Yes.
Then I'm going to find the critical values of x. Before I say less than 0, I'm going to find the actual values of the critical values of x. So I've got my function 6x squared minus x minus 2. I'm going to equate it to 0. Then I'm going to find the product, the sum, and the factors. So the product, 6 times negative 2, I'm going to get negative 12. The product, the sum, is the coefficient of x, which is negative 1. The factors are negative 4 and 3, such that if I say negative 4 times 3, I'll get negative 4. Negative 4 plus 3, I'll get negative 1. So the critical values of x are going to have 6x squared. I'll substitute on the sum. I'll say plus 3x, then minus 4x minus 2. This is equal to 0. Then factorizing 3x is common. 3x into 6x squared, I'm going to have 2x. 3x into 3x, I'm going to have 1. Then what is common here is minus 2. Minus 2 into 4x, I get 2x. Minus 2 into minus 2, I get plus 1. This is equal to 0. So I'm having 3x minus 2, then 2x plus 1. This is equal to 0. Then finding the critical values of x, 3x minus 2 is equal to 0, or 2x plus 1 is equal to 0. That comes together. 3x is equal to 2, and it is divided by 3, by 3x is equal to 2 over 3, or when the 1 goes that side, I'm going to have 2x is equal to 1 over 2 over 2, or x is equal to negative 1 over 2. Okay? So now I found the critical values of x of this function. Then I'm going to put these numbers on a number line. I'm going to put these values on a number line. The critical values of xi. So on the number line, I've got 0, negative half is on my left hand side, negative 1 over 2. Then positive 2 over 3 is right 3 after on the positive side, 2 over 3. Then I'm going to find the ranges. So these same values which are found here, I will just find the critical values. I can get this function which is here, the ranges. So the first range will be from here to negative infinity. So the first range, so I will draw a table. I'm going to draw a table. I'm going to have ranges. The first range for me it is from negative infinity to negative half. That's the first range. The second range is between negative half and 3 over 2. The third range is from 2 over 3 to positive infinity. So these are the ranges that I have. The first range is from negative infinity to negative half. The second range is from negative half to 3 over 2. The last range is from 3 over 2 to positive infinity. Okay, so now my factorized equation is this one. I'm going to get this one. Then I'm going to replace it. I'm going to be finding values which are in this range. So the function that I have, I've got two factorized equations. I'm going to get the factorized one, 3x minus 2. Going to put it there. Then 2x plus 1. 2x plus 1. I'm going to then I'll be getting values in this range when replacing in the both equations. So for example, if I pick a value that is in this range from negative half to negative infinity, I can pick a value of negative 1. It is on my left hand side. So if I put negative 1 here, times negative 1, I'm going to get negative 2. Negative 2, negative 3 times negative 1, I'm going to get negative 3. Negative 3 minus 2, it's negative 5. So the result of this function will be a negative value. Again, if I pick the same negative 1, I put in this equation. 2 times negative 1, it's negative 2. Negative 2 plus 1, I'm still going to get a negative value. Then here I'm going to have the product of the two signs. Then negative times negative, the result is positive. Okay? Then again, I'm going to pick a range between negative half and 2 over 3. I can use a 0. So if I plug in a 0 in this, 3 times 0, it's 0. 0 minus 2, it's negative 2. So if I plug in a 0, I'm going to have a negative value. If I plug in a 0 in the second equation, 2 times 0, it's 0. 0 plus 1, I'm going to get a positive value. So negative times positive, I'm going to get a negative value. This is the testing table. It's called the testing table. Then from positive 3 to positive infinity, I can pick a value of positive 1. So if I pick positive 1, 3 times 1, it's 3. 3 minus 2, it's 1. So I'm going to get a positive value. If I plug in a 1 in my second equation, 2 times 1, it's 2. 2 plus 1, 3. I'm going to get a positive value. Positive times positive, I'm going to get a positive value. So now the question says, find the range, the interval, for which the function is decreasing. So the function is decreasing where the product is a negative. The function is decreasing where the product is a negative. Therefore, range interval for which the function is decreasing is, why it is negative here, so it's from negative half to positive 3 over 2. Negative half to positive 3 over 2. This is the range where the function is decreasing. Okay, so that's the range where the function is decreasing, it is negative. Then I've got another question. Question B. We have this. Question B. Then the second one, I'm finding the interval for which this function is increasing. So for this function to be increasing, it means that my f prime of x will be equal to, I'm going to differentiate this function. The first derivative of this function, if the function is increasing, is greater than 0. So my f prime of x, because I'm going to differentiate this function, so negative 2 multiplied by the power, then the power is reducing by 1, then minus 9 multiplied by 2, then the power is reducing by 1, minus 12 times 1, the power of this is 1, it's invisible, there is a 1 there, x, 1 minus 1. Then the derivative of the constant is a 0, so I'll not write it. So my f prime of x will be equal to negative 2 times 3, I'm going to get negative 6. F 4 times 1 is just 4. Then 1 minus 1 is 0. The derivative of 1 is just n, 0. I won't write it. So my f prime of x is going to be negative 6x squared minus 18x. X to the power 0 is 1. 1 times negative 12, I'm going to get negative 12. So this is my question. So we are saying for this function to be increasing, the first derivative, negative 6x squared minus 18x minus 12 must be greater than 0, meaning the function is increasing. Then let me find the critical values of x, the one which I'm going to put on the number line for testing, for finding my intervals. So I have minus 6x squared minus 18x minus 12 are going to equal to 0. Then the product, negative 6 times negative 4. If I want, I can reduce this function by dividing throughout by 6, even there by 6, even there by 6. What I do on the left hand side, I also do on my right hand side. So I'm going to have negative x squared, 6 into 18, I'm going to have minus 3x, 6 into 4, we're going to have minus 2, this equal to 0. My product, negative 1 times negative 2, I'm going to have negative 2. My sum is just negative 3. My factors, the ones just that if I add, I'll get negative 3. If I multiply, I'll get negative 2. So the product is positive 2. Negative 1 times negative 2. The sum is negative 3. So numbers which I can multiply, it's negative 1 and negative 2. Negative 1 plus negative 2, I'm getting negative 3. Negative 1 times negative 2, I'm getting a positive 2. So I'm going to have negative x squared minus x minus 2x minus 2. This is equal to 0. Then I can factorize what is common. It's minus x there. I'm going to have x minus x into minus x. It's plus 1. Here it's minus 2. X minus 2 into minus 2 is plus 1. When you're factorizing, what is in the brackets has to be the same all the time. And I'll just get minus 2 minus x minus 2, then x plus 1 is equal to 0. Finding the critical values of x, minus x minus 2 will be equal to 0. So minus x will be equal to 2, x will be equal to minus 2, or x plus 1, x plus 1 will be equal to 0, x will be equal to minus 1. So these are my critical values. Then I'm going to draw my testing table so that I know the interval where the function will be increasing or it will be positive. So I'll draw a number line to find the intervals. I'm going to draw a number line. Then on the middle of 0, on my left hand side, I have negative 1, on the other end, I have negative 2. So the intervals starting from here, going this side, going from here to here, then from here, going this side. So from here to here, I can say it's from negative 2 to negative infinity. Then in this range, from negative 2 in this range. From negative 2 to negative infinity. In this range, negative 1 to negative 2. Then in this range, 0 to positive infinity. Those are my intervals. Those are my intervals. Then I'm going to draw my testing table. Testing table. Testing table. Here I've got interval. Then we are the sum. The intervals are got from negative 2 to infinity, negative 1, negative 2. And my other is from negative 1 to positive infinity. My other from negative 1 positive infinity. Okay, so I've got 3, and here I'm going to say product of signs, product. Okay, so now here I've got the inequality. Let me have the inequality here. Then the sign here. Okay. So if I pick a value in this range, I can pick negative 3. The inequality, the first inequality, the one which I have factorized is negative x minus 2. The other one is x plus 1. X. So now, if I pick, I think I've interchanged the columns. Let me draw my testing table nicely. Draw my testing table. So here I can have the intervals. Here I can have the intervals. The intervals, I have negative 2 to negative infinity. The other interval, I have negative 1 to negative 2. And the other interval, I have negative 1 to positive infinity. Then here I'm going to say inequality. The inequality that I have, here I can say inequality. The inequality that I have, I've got minus x minus 2 then the other one, x plus 1. This is my testing table. Then here I'm going to have the signs. So if I pick -3, I plug in there -3, I'm going to have -3 times -1, I'm going to have +3. So in this range, it will be positive. If I pick -3 again, I plug it there, it's going to be negative. Then the product positive times negative, I'm going to have a negative. If I pick between -1 and 2, I can pick -0.5. I put -0.5 there, negative times -0.5, 0.5. I'm going to have a negative value. If I pick 0.5 there, I'm going to have positive value. Negative times positive, I'm going to get a negative value. If I pick from -1 to positive infinity, I can pick 0. If I put 0 there, I'm going to have a negative value. If I put 0 there, 0 plus 1, I'm going to have a positive value. Negative times positive, it's negative. So the question is asking us to find the range of the function where it is increasing. So I can see that the product is all negative. So I can conclude the conclusion there is no interval. There is no interval where the function is an empty set where the function is increasing. Or we can say it is an empty set. Yeah. So this is what I had for you in today's video. We're looking at increasing or decreasing functions. When a function is increasing, the first derivative must be greater than 0. When a function is decreasing, the first derivative must be less than 0. So this is what we had for you in today's video. Thank you for watching. If you view this, kindly share with your friends and subscribe to more videos like this. Thank you. Bye.